Hello mates, my name is Arjit Kedia, Computer Science Branch Section B. Here I am presenting you the experiment number 9 Thermo Couple. So basically first thing I want to tell you that the simulator part is so easy in that, but the theory is important, so you must take some focus on the theory. Okay, let's start. Let's see what is the aim of this experiment. The aim is to just to verify the EMF. Basically we got a temperature difference and some conductor and we have to find EMF. So let's start. First we go through the theory part. Let's see. In 1821 John C. Beck observed that when they took two dissimilar matters and a temperature difference was made, the compass of his was just deflected. So why this deflected? So he realized it should be induced electric current. But induced electric current can be made by some potential difference. So so after the conclusion, the thing that make this is some EMF. So first question arises is that why we are taking the two different materials. The reason for the taking the two different material is basically when we took same material, the temperature, the EMF between them cancel out between each other. So we have to take two different material. So as you can see below my slide that there is a formula V is equal to ATH minus TS. So there is a temperature difference and a coefficient and we got some voltage. So see there are there are three principles which govern this experiment. First is Seebeck effect, which you see that the EMF is produced by the temperature difference. Peltier effect. Let's see that the Peltier effect is nothing much more. It is just the reverse of the Seebeck effect, that the EMF, if there is EMF, we got a temperature difference. Thomson effect. Thomson effect is basically reversible thermal gradient or EMF in a homogeneous matter. So Seebeck voltage, we got Seebeck voltage formula at last, alpha T minus T naught plus beta T minus T naught square. Since thermocouple voltage is a function of temperature difference, so we have to consult both voltage and reference temperature is must. After all, let's see, if we have reference temperature, we have alpha, we had beta, we got the and we also have EMF. By calculating, we got the temperature of higher degree. So the experiment going on, how we perform the simulator. So in simulator it's very simple. You have to just choose a thermocouple type and adjust the temperature, and we got EMF and we have to make a graph. So let's continue. We have to move to experiment. So we click here and here is a simulator. See, there are two different temperature platform. First we took a reference, so we are going to take reference as 0 degree and we have to choose the higher temperature. As you can see that there are two different values. As I previous told you that the reason of taking two different conductor is to get different voltage, otherwise the whole system will cancel out and we got no particular EMF. Okay, so for so we choose different types: type R, type K, type E. Type R is platinum, rhodium. This is platinum and this is rhodium. Here is chromel, alumel, chromel, alumel. Uh, when we took type E, this is chromial, this is constant, and we can choose that also. Okay, so for experiment I'm going to choose type R. We took a reference as 0 degree and type R. Now we have to change the temperature, and by changing the temperature we got a temperature difference, and for temperature difference we got EMF. Okay, so let's see, I took the temperature 321 degrees Celsius. For 321 degrees Celsius I got EMF 2.607. Here in virtual simulator you got a graph like that, but in project you have to make the graph. For making the graph you can took different temperature points and draw the graph. It's basically the you can previously saw that that the definition is E is equal to alpha into T minus T naught. So here alpha is, should be linear. So the whole formula is basically a straight line. So when you draw the whole graph, you are getting somewhat straight line. Okay, so nothing much. You just have to took a temperature, and for that temperature you got a EMF, and you have to draw a graph. So that concludes the experiment. Thank you. My name is Arjit Kedia, section B. You can DM me on Instagram if you have any problem, and follow me. Okay, thank you.